office for Weather Mod. Top Award Peak, Alpine Meadows.
When I think I learn a lot from Jessi. He's been doing it a lot longer than I have, you know, the field work stuff. And what I appreciate about him is if things are going smoothly, too smoothly, he has no problem throwing a wrench in it just to practice and train, you know, and it's important. And I've learned a lot of stuff on days where we've done everything correctly, quickly, and he said, okay, now let's go get stuck and get unstuck.
It's a nice sunny day. There's a big tree and a snowdrift. It's winch training day.
Is this Navy Jessi?
I think it's just Jessi. The more I find out about him, it's like he gets a new toy and takes it apart and then puts it back together, then plays with it. You know, he wants to know how everything works.
We have Pat Melarkey, beautiful Lake Tahoe, and our heated weather icing detector, camera. Beautiful day in the Sierras. It does take quite a person for this job. Not only are you looking at the scientific aspect, but also the outdoor aspect of traveling into extreme conditions and dealing with whiteouts on the road and backcountry snowmobiling and being aware that Murphy's Law is going to come into play at some point, that if something's going to go wrong, it's going to happen while you're out there. And that's one of the big things of always having your head on a swivel, and that's one thing that having someone I can trust in the field to know that he can get me out of any sticky situation and vice versa. And we're usually in very remote locations, so once you're out there, and there's been plenty of times that we're working into the night with headlamps and coming out in the dark with the headlights on our snowmobiles. So.
You get to know people pretty well when you're occupying the same cab in the truck. And yeah, we definitely have different ways of doing things, but we always learn from each other, so that's kind of fun. Yeah, we got a lot of scribbles on legal pads in the truck and come up with solutions to problems, and then we get to where we're going and we're like, wait, didn't we already solve this once? Oh yeah, that was on the way to Southern Colorado.
Weather Mod up here today at Blue Ridge, Fraser, Colorado, servicing one of our cloud seeding generators. At the very basic concept of cloud seeding, every snowflake has a small dust particle, a nuclei that snowflake forms upon, whether it's dust from the Sahara sand dunes, whether it's volcanic ash, whether it's you burning a wood fire in your wood stove in your cabin at Lake Tahoe, whether it's starting up your car. There's so many inadvertent forms of cloud seeding, but we're specifically introducing the ideal size, shape, and crystalline structure of dust particle so that the water molecule can grab onto it, grow, and fall out in our targeted area. Here at this shop, this is what we do. This is the exciting part. We get to innovate and build these cloud seeding generators right here in this shop. So this test stand has a bunch of different components, simulates what we have out in the field in the big trailer style. Battery powered. It has a liquid propane tank for the fuel source. It has a containment vessel for our cloud seeding agent, the silver iodide and sodium iodide. And then it has a nitrogen, dry nitrogen, that pressurizes that tank and pushes it through the plumbing system. On this side, you can see this is a burner, just like a big barbecue burner. And at the top is ignited by just a spark igniter. And so with this nozzle, one side is solution, one side is a gas, atomizes the cloud seeding solution and sprays it into the propane flame. You might see that there's a little dent in this door. That angle that it's introduced into the flame is even critical. So there's so many aspects of this. Underneath is thermocouples, which measure the flame's temperature, so we know that it's at a right temperature to introduce that seating agent into, so it forms the right size and shape particle, just like every snowflake. The hexagonal crystalline structure, that's what the silver iodide is, and that's what the water molecules attract to. So when we start it up, we'll start the igniter, add the propane, and you'll see a flame. So that's the propane flame that's burning. And then what we'll do on this relay is introduce the cloud seeding solution into that flame, and you'll see it change from the blue liquid propane flame to a silver iodide flame. So right now there's thousands of microscopic particles being introduced into that flame. The acetone and propane burn off, produce heat, turn into carbon dioxide, and all that's left is the silver iodide molecule. And that's introduced into the cloud. Good morning, DRI. It is December 15th, 2022. This morning instead, there was freezing fog covering the whole valley. So we turned on our cloud seeding generator at the Stead facility. And just as expected, we created a hole punch cloud in the fog. Silver iodide nuclei have grabbed the supercooled liquid water from the freezing fog and is precipitated out into small diamond dust snowflakes. So this area instead is clear due to cloud seeding. It's really interesting. The water master has a huge balance to take care of. He only has 6 feet of Lake Tahoe that he can release down the Truckee River. And he has to be aware of how much snow is being captured in the mountains, how much he can release, so that you don't end up in the middle of the summer and have the Truckee River dry. No fish flow, no water going down.
Cloud seeding is a tool in the toolbox to help drought. It's not going to fix it. It's not going to miraculously end drought, but it can help alleviate the stresses of drought. It's not like a magic bullet or something like that, but it is a tool in the toolbox that helps as drought stresses pile up.
So I think an important aspect is to know what each generator can contribute to this snow augmentation process. Each generator can hold up to 170 gallons of seeding agent, and that can be released throughout the whole season. And that each generator can produce over 3,000 acre feet. And I think it's important to kind of quantify that. How much is an acre foot? That's one of the questions we get a lot. And half an acre foot is usually what an average household uses all year. And our normal annual contribution, for an example, to the Lake Tahoe area over the past years is 10,000 acre feet added to the watershed. That's roughly 3 billion gallons of extra water that wouldn't have fallen out if we didn't introduce that seeding agent, that dust particle. This knowledge of cloud seeding and this application of using science to augment water is being used not only to refill reservoirs and lakes, but it's also part of the hydroelectric community. All the power companies are using this technology to fill reservoirs that feed the power system. As part of DRI, we're actually helping increase that flow rate as it's coming down the Truckee. The relationship of the mountains being our resource battery, adding that snow in the winter and then depleting the battery during the summer months as it runs down the watershed. It's pretty important to make sure you have a good stockpile. And I kind of relate it to a piggy bank. It's impressive when you pull dollar bills out of your wallet and you can stack them up. But sometimes there's that loose change. There's the nickel and dime that you just throw in the bank every now and then. And that's the cloud seeding. That's that nickel and dime that you throw in, and all of a sudden you have a full piggy bank at the end of the season.